Good morning. Today we will be seeing about the concept of multiplexing, which means sharing a medium. So basically, multiplexing is a technique that is used to combine and send multiple data streams over a single medium. So the process of combining multiple data streams is known as multiplexing, and the hardware that supports the concept of multiplexing is known as multiplexer. So multiplexing is basically achieved by using a device called as multiplexer. In short, we can call that as MUX, which actually combines n input lines to generate a single output line. So multiplexing follows the concept of many to one. So you have many input lines, in this case n input lines, and you have one output line. So next, coming to the concept of demultiplexing, which is actually a reverse process of the multiplexing concept. So in multiplexing, we saw that combining multiple signals into a single signal is called as multiplexing, whereas in case of a demultiplexing, we are going to make use of a device called as demultiplexer, or in short DMUX. This particular device will be available at the receiving end. What does this device do is that it will separate a single signal into its component signals. Component signals in the sense that you have n different output signals. So here, in case of a demultiplexer, you will be having one input signal and n output signals. Therefore, we can say that demultiplexing is a concept of one-to-many approach, whereas multiplexing is the concept of many-to-one approach. So in this diagram, you can see that we have a MUX at the source side and DMUX at the receiver end, and they are connected through a channel. So in case of a MUX, you have n input lines which is combined to a single signal and transmitted over a channel, and in case of a DMUX, you have a single input which is separated into n output lines, and each of these signals will be transmitted to their corresponding destination. So that is what happens with the help of a demultiplexer. Okay, so here you can see that we call the single signal as a composite signal, which is passed through a demultiplexer, which will separate the signal into component signals and transfers them to your respective destination. So why multiplexing is important? So we can say that we make use of a transmission medium for sending the data from a sender to a receiver. And this particular medium will be able to have only one signal at a time. So what will happen when multiple signals are trying to share the same medium? So in that case, the medium has to be divided in such a way that each of the signal is given some portion of the available bandwidth. So for example, here we can see that we have 10 different signals which is actually trying to access the medium which has a bandwidth of 100 units. So what can be done in this case? You can split the bandwidth and provide 10 units to each of the signal here. So when multiple signals share a common medium, you can say that there is a possibility of collision, and hence this multiplexing concept is actually used to avoid such collision. And also, since the transmission services are very expensive, multiplexing will be helpful in transmitting multiple signals using the same medium. So that is why we go for the concept of multiplexing. In short, to say the advantages of multiplexing, we can say that more than one signal can be sent over a single medium, and the bandwidth of the medium can be utilized effectively. So coming to the multiplexing techniques, there are different techniques. So the first one is the frequency division multiplexing, time division multiplexing, wavelength division multiplexing, and code division multiplexing. So in this topic, we will be seeing only about frequency division multiplexing. So coming to the frequency division multiplexing. So frequency division multiplexing is a networking technique in which multiple data signals are combined for simultaneous transmission via a shared common medium. So multiple data signals are trying to access the same communication medium for its transmission. So in this case, what happens is that the FDM technique makes use of a carrier signal for each of the data streams. So you can see that there is a communication medium which is split into different frequency bands, and each of the medium is given a separate frequency band which with which they will be able to transmit the signal. So here you can see that these frequency bands are called as the carrier signal. Okay. So when FDM is used to allow multiple users to share a single physical communication medium, that particular technique is called as frequency division multiplexing, because you are dividing or providing multiple access to many users at the same time by dividing the frequency band. So here FDM is an analog technique, and here in this example you can see that the frequency range, the entire frequency range is divided into many frequency channels, and each of the device is given a certain frequency channel with which they will be able to transmit the data. So the entire medium is split in terms of frequencies, and each of the user is given a particular frequency so as to transmit. So here a single transmission medium is subdivided into several frequency channels, and each frequency channel is given to a different device. So what this device will do is that they take the input signals, they translate into the frequency band by using modulation techniques. So once it is modulated, then they are combined by the multiplexer to form a composite signal, and this composite signal is transmitted through the medium. So the main aim of frequency division multiplexing is to subdivide the available bandwidth into different frequency channels and allocate them to different devices. So in this case, the different frequency channels are called as carriers, okay, and they are represented using the denotation F1, F2 till Fn. So we have n frequency channels. So this diagram shows that here you can see that this is the common channel. Okay, so the common channel is divided into different frequency channels, and for data 1 they have given the blue slot, for data 2 the yellow slot, for data 3 green slot, for data 4 it is pink slot. So each and every channel is given to each of the users with which they will be able to modulate the signal and transmit it through the common channel. And in this diagram, it is very clear that we have the baseband or analog signals here. These are the original signals that we would like to transmit through the common medium. And the medium is now subdivided into different frequency bands with carrier frequencies F1, F2 and F3. So the first user makes use of this carrier frequency for modulating the original signal, and this is the modulated signal, and the same way we have the modulated signal for second and third, and all these three signals are combined together with the help of a multiplexer here, and they are combined into a single composite signal which is passed through a common medium. And at the receiver end, again the composite signal is received with the help of a demultiplexer, which is split into different component signals, and first a filter is used to remove the noise which has been included in the transmission process, and once the noise is removed, the signal, the modulated signal is demodulated with the same carrier frequency, and the original baseband analog signal is obtained. So this is how multiple signals can be transferred over a single common transmission medium. So coming to frequency division multiplexing, we know that analog signals are basically use this particular frequency division multiplexing technique for transmitting the signals over a common medium. Some examples would include broadcast radio and television, cable television, and AMPS cellular phone systems. And this is one of the oldest multiplexing techniques, and since it involves the analog signaling, it means that it is more susceptible to noise. So here this table just shows different channels and their corresponding frequency ranges. So coming to the advantages of FDM, so this particular FDM technique is used for analog signals, and this process is a very simple and easy modulation process, because we are just going to make use of the carrier signal for modulating it. And then we can see that a large number of signals can be sent through the FDM simultaneously. And here, in case of a frequency division multiplexing technique, there is no synchronization required between the sender and the receiver. Coming to the disadvantages, FDM technique is used only when low speed channels are required, and it also suffers from the problem of crosstalk. And here, since you're making use of the carrier frequency for modulating each and every signals, obviously a large number of modulators are required, and it also requires a high bandwidth channel. Only if the bandwidth is high, you will be able to divide it into smaller frequency band and assign it to the users. So coming to the applications, as we discussed earlier, the frequency division multiplexing technique is mainly used in radio broadcast and TV networks, and it is also used in FM and AM broadcasting. So each FM radio station will have different frequencies which are multiplexed to form a composite signal, and this particular multiplex signal is transmitted in the air. So thank you.